All right, today's lesson will be on 3.4, the trigonometric ratios. By now, you should be familiar with the primary trigonometric ratios. So there are three primary trigonometric ratios. That is sine, cosine, and tangent. So whenever the word ratio is mentioned, you should be seeking one of potentially these three. If we are on the unit circle, and the radius vector has length 1, it follows that sine theta is equal to y, cosine theta is equal to x, and tangent theta is y over x. We all know that. So maybe as an alternate way we could write this is I could also state that tan theta can be, since it's y over x, can be written as sine theta over cosine theta. Or alternatively, we have thought that tangent theta is equal to the slope. This isn't new to us. What will be new to the lesson is the reciprocal trigonometric ratios. So there are three reciprocal trigonometric ratios: cosecant, secant, and cotangent. Now, cosecant is 1 over sine. Secant is 1 over cosine. Tangent is 1 over tan theta. Or we could also, cotan theta is equal to 1 over tangent theta. We could always write that as x over y, since it's the reciprocal of tan. Also, cotan theta, if it ever comes up, and I don't know when it would, but we could write it as cosine theta over the sine of theta. All right. Example 1. Determine the trigonometric ratios, not radios, for the angles on the unit circle. The point 5 over 13, comma, negative 12 lies at the intersection of the unit circle and the terminal arm of theta. Draw a diagram to model this situation. So here's my Cartesian plane. I'm going to have a circle with a radius of 1, and this would represent my unit circle, so radius 1. And on my terminal arm, I have the coordinate xy, 5 over 13, comma, negative 12 over 13. And that really puts it in quadrant number 4. So there's my terminal arm, and that's the situation that I'm talking about. Maybe just for extra clarification, I want to write my coordinates of that point, and that's 5 over 13, comma, negative 12 over 13. So I am to determine the 6 trigonometric ratios for theta. Well, fair enough. Let's get started. So first off, I'm just going to pick sine theta. Now, sine theta would be equal to negative 12 over 13, since it's on the unit circle. Cosine theta would be equal to 5 over 13. And tangent theta might require a little bit of work. Tangent theta is the sine divided by cosine, if you wish, or the y divided by my x. And what I get here is tan theta is going to be negative 12 over 13 divided by 5 over 13. I'm just going to carry that work up here. So tan theta, if I simplify that, that is going to be negative 12 over 5. Perfect. So that's for the three primary trigonometric ratios. Let's go for the reciprocal trigonometric ratios. And I know that cosecant theta is equal to 1 over the sine of theta. Now, let me just highlight something. I'm going to ask you, how would you say the highlighted portion in English without using any mathematical technology, really? Well, maybe so. The easiest way to say 1 over sine theta is call it the reciprocal of sine. And it's really quite intuitive for students to take the reciprocal. So cosecant theta, and I'm going to look at the sine value. The sine value was negative 12 over 13. And what I have here is cosecant is equal to 1 over negative 12 over 13. A better way to say it is the reciprocal of negative 12 over 13. So therefore, the cosecant theta would be 13 over 12 negative. Fair enough. Now I'm going to do secant. And secant theta is the reciprocal of cosine. Now you could take a look at the cosine ratio and ask yourself, well, what is the reciprocal of 5 over 13? And that's 13 over 5. We could formally write this, though, as the secant theta is 1 over 5 over 13. And when you simplify that, we would get secant theta is equal to 13 over 5. Now, if you're wondering how we could quickly do that, I'm just going to erase this work here. 1 over 1 divided by 5 over 13. You would multiply by the reciprocal of the denominator, and you'd end up with 5 over 13. Last but not least, now cotangent, switch colors. Cotangent theta is the reciprocal of tangent theta. And the reciprocal of tangent theta here, well, it would be cotan theta is equal to 1 over negative 12 over 5. And very easily, I think you can see that would be 5 over 12 on the negative. I hope that this is good. Now, I'm going to stop the video there, and then we're going to move on.